Hi everyone, my name is Tae-Shin in Smart Content Major of ICT Commerce Division at Pyeongtaek University. Our presentation today is about blockchain-based lightweight transaction process modeling and development. We proposed a new blockchain process model we called lightweight transaction to minimize the use of system resources, and we modeled the lightweight transaction architecture and applied it to several application services. Presentation order is as follows. First, we define new concept lightweight transaction equals L.TX and look at background technology used in L.TX. Section 2 introduces L.TX architecture and new coin based on the L.TX named PTC. Section 3 explores that L.TX process-based blockchain vending machine application service. Finally, Section 4 discusses the conclusion and future challenges of this study. The first thing to look at is what lightweight transaction is. Lightweight transaction is a new concept to minimize the use of system resources between blockchain and nodes to ensure normal operation of blockchain process, even in low-performance device. The following figure is a brief representation of the lightweight transaction architecture concept. It utilizes of the blockchain model to form heavyweight blockchain and lightweight blockchain. The role of lightweight blockchain is to regularly broadcast a new lightweight block set collected in heavyweight blockchain. Overall, the role of heavyweight blockchain is similar to existing blockchain systems, for example, Bitcoin blockchain systems. Difference from existing systems include logic to validate blocks broadcast by lightweight blockchain. Before we look at the detail of L.TX architecture, let's look at the core components and technologies used in L.TX. L.TX has three core components: asymmetric cryptography, blockchain transactions, and consensus mechanism. The following figure shows the core elements of the blockchain. Each element contains a different logical layer. Asymmetric cryptography contains security logics, and blockchain transactions has an input-output payment logic. And the consensus mechanism contains verification logic. The next part is background technology used in L.TX. First, L.TX used ECDSA when generating a public key from a private key. ECDSA is a cryptographic algorithm that combines an elliptic curve cryptography equals ECC with an electronic signature and is widely used in cryptocurrencies. The following equation and graphs shows the elliptic curve equation used in ECDSA. There are many types of elliptic curves that satisfy the equation, but only a few curves are used in the elliptic curve encryption method. A typical elliptic curve used in many cryptocurrencies, including Bitcoin, is an elliptic curve using the SCCP-256K1 parameter defined in Standards for Efficient Cryptography equals SCC, and L.TX also used SCCP-256K1 based elliptic curve. Second, L.TX uses a consensus algorithm of the proof of work method. Proof of work is participating nodes solves complex puzzles such as calculating hash values less than a randomly changing target value. So, it is similar to mining gold. Now, let's look at the L.TX architecture. The lightweight transaction architecture equals L.TX dualize the blockchain model to maintain the verification of the blockchain while reducing the weight of the blockchain. The following figure shows the L.TX based blockchain structure. L.TX has a dualized blockchain model defined as a lightweight blockchain and a heavyweight blockchain. Lightweight blockchain is formed between each lightweight node, and a heavyweight blockchain is formed between normal nodes with power computing. First, the initial blocks of the lightweight blockchain branches and receives the last verified block of the heavyweight blockchain network. Second, transactions occurring in the lightweight transaction network are securely collected and stored in a lightweight block and repeat this process until certain conditions are met. Third, when the number of blocks of the lightweight blockchain is more than a certain number, or the execution time of the lightweight transaction reaches the synchronization time limit, the blocks of the lightweight node are broadcast to the heavyweight blockchain to join the blockchain network. Therefore, these blocks became part of heavyweight blockchain. Fourth, in the heavyweight blockchain, if the block of the heavyweight blockchain are properly verified and reflected, all blocks in the lightweight blockchain are deleted after the certain period of time, and the subsequent lightweight blockchain creation process is continuously performed. This slide is a text representation of the heavyweight blockchain described in a previous figure. If you have any question, please ask us after the presentation. Also, this slide is a text representation of the lightweight blockchain described in the previous figure. If you have any question of this part, please ask us after the presentation. Next, I will introduce Pyeongtaek coin equals PTC, a new coin based on FTX architecture. Pyeongtaek coin equals PTC is a new coin model created by forking the coin base of Litecoin, a model that improves Bitcoin. The purpose of Pyeongtaek coin equals PTC is to curb inflation, which is a problem of cryptocurrency, and to use cryptocurrency in real life. It aims to be used with local currency when recognized as money and introducing regulations. By changing only some parameters of Litecoin, it maintains anonymity, an advantage of card system and differentiated blockchain. It develops the client by modifying it to suit actual case, not just some numerical changes. The following are the characteristics of the PTC. First, the fast block generator time. Create blocks quickly to induce quick agreement. Second is non-existent half-life. It enables inflation in coins by not having a half-life. Third is low unit amount. The value of the unit amount of 1 PTC should be close to $1. To realize a low unit amount, the block reward must be high, and the total interest of coins must be increased. The fourth is apply lightweight transaction. LWTX enables client to operate even in poor hardware environments. Fifth is apply smart contract technology. It is designed to be suitable for real-life use with smart contract technology. And the last is final goal of PTC. It is used as a local currency in cooperation with local governments. The following figure shows an existing blockchain system and a new blockchain system based on LWTX. The difference in the new system is that the client was realized by applying the LWTX concept. This is a heavyweight client, and this is lightweight client. The last part of section 2 is the comparison between PTC and other coins. PTC has reduced the block generation cycle to 1 minute to shorten the minimum verification time of the blockchain and has the intention to reduce the value of the unit amount as much as possible by increasing the mining reward and total insurance. Also, since there is no half-life, it prevents the price of coin from rising rapidly every half-life. The topic we will discuss in this section is example of LWTX-based application service. The following figure shows an example of LWTX-based application service. We would like to describe the application process that applied LWTX to vending machine among these various application services. By applying LWTX to vending machines, customers can use it without burden by realizing fast agreement time and low unit price. The LWTX-based vending machine must be at modus for cryptocurrency transactions similar to card transaction for cryptocurrency transactions and include the exchange API to synchronize the market price. The following figure shows the application of out-of-TX to vending machines. This figure shows example of vending machine service, and this is PTC client to process blockchain logic. The following flowchart shows the cryptocurrency-based vending machine service algorithm. At this stage, check the wallet address of the buyer with QR code. And the next stage, a script is created in the vending machines, such as a transaction and a smart contract, and broadcast it to the blockchain network. If it is normally broadcast on the blockchain network, the product is delivered to the buyer. This study a good alternative to the application environment where normal block hash calculation ability and electric power based on a large-scale blockchain network are burdensome. Nevertheless, there remains a problem of how suppress the biased inflation of issued cryptocurrencies. Future research intends to propose the technical method to improve inflation in cryptocurrency based on the proposed lightweight blockchain process and apply out-of-TX to various application services. Furthermore, we will expand to a study on the consensus algorithm optimized for out-of-TX. Thank you for your attention. Do you have any question? Welcome any comment or question. I'm Tae-Shin from Pyeongtaek University. Thank you.